For this video, we are finding the area bound by the curves y equals 2 minus x squared, which is this parabola, and the line y equals negative x, the linear function. So the first thing that I do when I'm actually finding an area is I check to make sure, well, to tell whether it's a dy or a dx problem. And usually I try dx first. So the way I actually check is I'll look at both functions. And it's the word I'm actually using that tells you they're both functions. So when I look at that and I start drawing little vertical lines, the top of each one of my vertical lines always touches the parabola, the bottom always touches the line. That tells me two things. One, that they're functions, they're passing the vertical line test. For every x there's exactly one y, which helps me do a dx, but also tells me that this will be one integral, because if that's not true and I'm switching either my more positive function or my less positive function, then I'm going to have more than one integral. So the next thing, my little lines, basically the way I think about it is these represent itty bitty 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 thin rectangles, and I'm going to add them up. I start adding them up here where the functions meet, I end adding them up here where the functions meet. So I'm adding up the distances from this x value to this x value. So each one of those distances can be represented by taking the more positive function. In this case, the more positive would be the ones that the top of the little line segments are hitting. It's the function up here, it's the parabola, and then the less positive function down here will be subtracted from it. So our more positive function, the parabola, is 2 minus x squared, and I'm going to subtract the less positive function. So I'm going to subtract a negative x, or plus x, and this is with respect to x. What I need now are my limits of integration. So it's where do you start adding up your line segments or your little distances, where do you end? So I start adding them up where the lines intersect, and I end where the lines intersect. So to find that, I want to figure out when the lines are the same. When does 2 minus x squared equal negative x? So I'll solve this equation, and this is quadratic. So I'm going to set it equal to 0, and I'm going to move everything to the right. So I have 0 equals a positive x squared minus x minus 2. So 0 equals, and I'll factor it, x minus 2 times an x plus 1. So x equals 2 or negative 1. So this x value is negative 1, this x value is 2, and those are my limits of integration from negative 1 to 2. So when I actually do the antiderivative and evaluate the antiderivative at 2 and negative 1 subtract, first fundamental theorem, I would have the area of this shaded region right here.